let us now see what is adaptive control. In adaptive control, we identify a model for the plant we are controlling at the same time that we control it. We have seen in the video series about system identification that it is possible to have here a model for this plant, obtain here an estimate of what this output should be. Then, if we have here a sensor, we will have here our measured output. We compare our measured output with the output we are expecting from our model. This is the modeling error, and from this modeling error, it is possible to use an identification algorithm that will change the parameters of our model. Since we now have a model, we can use the parameters of this model to find a controller using the techniques that we have just seen. To follow a reference, or to follow a constant reference with a regulator. And in that case, this controller here is being modified in real time by this model, which is being identified in real time. The controller, of course, works based upon this closed loop error, which is the difference between the reference and the measured output. So here is what is going on in each sampling instant. We measure the output. We know the input that was applied. We know the output that our model provides. From these things, we run an identification method that improves iteratively the parameters or coefficients of our model. This model is then used to design a controller. The controller, based upon the reference and the measured output, finds a control action, which is then applied. And in the next sampling instant, everything is done again. This is adaptive control, because the control adapts itself to the model which is being identified in real time. Adaptive control brings several problems. You may remember that these identification algorithms can get unstable. Our model can go astray. Also, the controller can become unstable if our model is not good enough, or if I'm using an algorithm that doesn't account, for instance, for non-minimum phase zeros and tries to cancel them. Even the change of the controller may bring me trouble, because if this change in the identified model is very fast, the change in the controller will also be very fast, and the variation of the control action will be big, and this may cause me instability in this control system. There are several things we could study and do to check that adaptive control is stable, but we will not enter into details. Just get this idea and know that identification is a very important part of control when we are dealing with stochastic systems.